The sun, it's a giant ball of blazing gas. We rely on its light and warmth, but the sun also has a fierce side. It can unleash bursts of energy called solar storms. These storms are powerful events. They can disrupt our technology and create stunning auroras. Solar storms originate from the sun's magnetic field. Think of it like a giant rubber band. Sometimes this band gets twisted and tangled. When the tension becomes too great, it snaps. The result is a release of energy. This energy travels through space at incredible speeds. These solar outbursts can take different forms. The most well-known are solar flares and coronal mass ejections. Understanding these events is key to grasping the sun's impact on our planet. Imagine a sudden flash of brilliant light on the sun's surface. That's a solar flare. These intense bursts of radiation release tremendous energy. It's like billions of atomic bombs exploding at once. Solar flares can disrupt radio communications on Earth. Then there are coronal mass ejections, or CMEs. These are massive eruptions of plasma and magnetic field from the sun's corona. Picture a volcano erupting, but instead of lava, it's a giant cloud of charged particles. CMEs travel slower than flares, but carry far more material. When a CME hits Earth, it can trigger intense geomagnetic storms. Both flares and CMEs are products of the sun's dynamic nature. They remind us that even our seemingly stable star is capable of incredible outbursts. When a solar storm hits Earth, it interacts with our planet's magnetic field and atmosphere. This can create a cascade of effects, some beautiful, some disruptive. One of the most stunning results is the aurora borealis and australis, also known as the northern and southern lights. These vibrant displays of color in the night sky occur when charged particles from the sun collide with atoms in our atmosphere. But solar storms can also cause problems. They can disrupt satellites, leading to communication outages. They can induce currents in power grids, potentially causing blackouts, and they can expose astronauts to dangerous levels of radiation. Scientists constantly monitor the sun for signs of solar storms. Using sophisticated telescopes and spacecraft, they track solar flares, CMEs, and other solar activity. This information helps us prepare for potential impacts. We're not helpless against solar storms. Power grids can be protected with safeguards to prevent overloads. Satellites can be maneuvered to minimize damage, and astronauts can take shelter during intense solar events. Understanding and predicting solar storms is an ongoing challenge. But with continued research and technological advancements, we can better protect ourselves from the sun's occasional fury.